The stress testing analysis option, available on the QX, QXL, and QXP instruments, provides additional SDI stress testing functions to complement your existing physical layer analysis toolset. The Advanced SDI Stress option is available for stress testing and R&D evaluations of SDI interfaces up to 12G. There are 3 additional instruments available within the stress testing toolset. Number 1, Eye. Number 2, Advanced Generation Tools. Number 3, PRBS Analysis. We're going to begin with the Eye SDI&A toolset. This instrument provides additional tools for stress testing and R&D evaluations of your SDI interfaces from 270 megabytes per second to 12 gigabytes per second. An analog front-end supplies a bandwidth of more than 30 GHz, fifth harmonic of the 6 GHz fundamental for 12G SDI. The GUI uses PHABRIX Real-Time Eye (RTE) to generate a reliable, AC-coupled, instantaneous physical layer display with automatic measurements to SMPTE standards. You can receive accurate measurements within seconds of connecting an SDI signal. The unit enables you to measure both rise and fall overshoots at the top and bottom of the waveform. In addition, the unit displays amplitude, rise and fall overshoot delta, and DC offset, all compulsory measurements when testing against SMPTE standards. The unit highlights any measurements exceeding the specification, for example an eye amplitude greater than 10%, in red. Working through all the features. Timing jitter thermometer, color-coded according to the analyzed SDI standard. Alignment jitter thermometer, color-coded according to the analyzed SDI standard. Positive and negative eye amplitude values. On-screen indication of 20% and 80% levels for rise and fall time measurement. Horizontal time histogram of eye crossing point, 0 megavolt threshold. Vertical amplitude histogram indicating energy distribution across all samples. Eye coupled to AC with display of DC offset measurements. A pair of vertical eye time cursors to generate and display time measurements across the eye display. Showing the distribution of samples over the complete visible eye waveform to calculate the automatic eye amplitude measurement. Using the eye time cursors. When enabled, the eye time cursors are displayed as a pair of vertical dashed lines when static. You can choose to position the eye time cursors independently or link the cursors together so that they move as a single unit with a fixed time separation. In addition, cursor readings below the trace display the time measurements in picoseconds, PS, from the start of the trace and show the delta between the 2 cursors. You can use the mouse connected to the unit to click, then drag a cursor or both cursors to a new position. When in motion, the dashed line of the cursor changes to a solid white line for improved visibility. You will see the time measurements below the eye change in real time as you adjust the cursors. The Physical Layer Analysis toolset provides the following options in the right-click submenu. Eyes. This sets the default number of eyes displayed in the instrument window from 1 to 20. Color. You can set the color scheme for the eye display. Eye and jitter filter. This sets the frequency of the default jitter filter. Infinite mode. When displayed, eye data points are displayed for a fixed persistence interval and then removed from the display. When enabled, infinite mode ensures that no data points are removed from the eye display over time, so you will probably observe the eye shape thickening and becoming less distinct. This can be useful when attempting to identify anomalies in the signal which appear sporadically over time and might be missed in the standard mode. Rise, fall, cross. Toggle the display of the rise-fall crossing point, which gives a visual indication of the rise and fall time measurements. The Advanced Stress Test toolset also offers the following options. The amplitude window, available in the Advanced SDI Stress Testing toolset, is an additional tool for more detailed analysis and measurement of the eye amplitude. Amplitude window offset. This is only active when the amplitude window size is set to any value between 0 and 99%. Use the offset to move the amplitude window to an optimum position on the eye for your measurement. A negative offset moves the window to the left and a positive offset to the right. Amplitude window size. The amplitude window is defined by the enclosed area containing the eye data points used for the eye amplitude measurements. All samples in the window area are used in the amplitude histogram measurement. You can use this option to define a window to focus on a specific part of the eye on which to take the amplitude measurements. When the size is set to the default 100, the amplitude window is the entire active window of the instrument. The size percentage relates to the percentage width of a single eye, so when set to 50%, the amplitude window covers 50% of an eye width and so on. We'll now take a look at the advanced generation tools available in the SDI-STRESS option. The advanced generation tools are provided in the Generator Instrument Options menu. The toolset provides the following: control over SDI scrambler switch off. The selected video standard data stream can be made to bypass the SMPTE scrambler just before the output stage. To bypass the scrambler, select Disabled. Sync bit insertion. Sync bit insertion prevents the occurrence of a pathological condition that results in the removal of sync bits, also referred to as potholing. Before the output, a sync bit is applied to the timing reference signal, TRS, and ancillary data flag, ADF, words of the generated video standards. To prevent sync bit insertion, deactivate this feature by selecting Disabled. You can observe the insertion of the sync bit in the video signal TRS and ADF words seen in the Analyzer Data View instrument when the option Sync Bit Removal is disabled. Sync bit removal function in the Data View instrument for 6G SDI and 12G SDI video standards. A PRBS pseudo-random binary sequence mode for end-to-end bit error rate testing. But, in addition to SDI test signal generation, for the stress testing of SDI infrastructure, the unit offers end-to-end BERT capability. With the addition of pseudo-random bit sequence, PRBS, generation and analysis tools. When enabled, you can generate a variety of PRBS signals on different bit lengths. SDI BER mode. The SDI BER mode function enables you to insert an SDI error to test CRC and CS errors. A bit error is inserted at the appointed time and can affect any word in the current frame or field of the SDI flow. Consequently, ANC words, video words, and audio words can all potentially be affected. Select either mode, single shot or constant BER, to activate SDI BER mode and display additional parameters. Advanced jitter generation controls. Facilitating the generation and bespoke adjustment of jitter measurement parameters. In order to stress the interface and ensure the receivers comply with SMPTE recommended practice, you can insert jitter into any generated SDI signal. You can insert sinusoidal jitter with a frequency ranging from 10 Hz to 10 MHz and adjust the peak-to-peak jitter amplitude. Slew rate adjustment. Adjust the slew rate of the generated signal from its default setting. Fast is the standard slew rate for 12G signals. Slow, 10% slower than fast, is the standard slew rate for HD, 3G, and 6G signals. Default automatically provides the standard slew rate for any signal being generated. SDI output gain control. Driver pre-emphasis. You can adjust the driver pre-emphasis for SDI out A to boost the signal at the beginning of the rising edge of the eye pattern to optimize signal integrity. Cable compensation. By default, the unit compensates for the attenuation across a 1 meter length of SDI cable to ensure that the eye amplitude at the end of the 1 meter cable meets the SMPTE standard. All these tools support a wide range of advanced testing and troubleshooting. The third key instrument available in the SDI-STRESS option is PRBS analysis. The PRBS analysis instrument displays the signal details, PRBS detection status, total amount of received pseudo-random binary sequence, PRBS data, total number of errors, bit error rate, burr per second, and OK time since last error for each SDI input link, BNC or SFP on the unit. The following parameters can set within the instrument. PRBS Auto Scan Mode. For SDI BNC inputs only, automatic PRBS analysis is available. By enabling Auto Scan Mode, the unit will automatically cycle once through all available PRBS analysis modes and select the correct mode for the incoming signal type. PRBS Analysis Mode. For BNC and SDI SFP inputs, you can manually enable PRBS analysis. When enabled, you can select the incoming PRBS signal type if known. For PRBS analysis on SDI SFP inputs, this parameter enables you to ensure the accuracy of the PRBS analysis by selecting the appropriate signal data rate and divisor. PRBS Signal Inversion. When enabled, this inverts the incoming PRBS signal.